We present AgentVis, an application for the visual analysis of agent call center behavior using hierarchical glyphs. The work was carried out in collaboration with our industry partner, QPC Limited, whom provide technology solutions for the call center industry. Our application relies on a data-driven scatter plot layout. Here we have loaded a month's worth of data provided by our industry partner. This consists of nearly 5 million calls who interact with over 6,500 agents. A scatterplot matrix is available to provide an overview of all variables. A correlation coefficient is used to indicate how well correlated each plot is, and the background color of each plot reflects this, with a darker red showing stronger correlation. Clicking a plot brings that plot into the main window. Users are able to map both the X and Y axes to a number of agent properties to explore relationships between variables. Here, the user selects the total hold count for the X-axis and the average agent customer effort score for the Y-axis. The user selects the glyph option to show a multivariate glyph for each agent. A selection of glyph designs are available to choose from. The chosen glyph design has 6 bars that can be mapped to an agent property as indicated by the glyph legend. The glyph legend is also used to represent the mean of all loaded agent variables. Hovering the mouse over the center of the legend returns a dialog with explicit average values for each agent property. Clicking the center of the glyph legend returns a dialog where each of the glyph bars can be changed as the user desires. The user in this case chooses to map the percentage of calls transferred to the 2 o'clock bar and the percentage of short calls to the 10 o'clock bar. The glyphs are updated accordingly. The length and color of each bar represents the value of the particular agent variable. The color map for the bar can be seen below the glyph legend, clicking which allows for a selection of color maps. Glyph centers are color-coded to indicate the call center department of the agent. Clicking the legend allows for a choice of color mappings. The user is also able to filter individual departments by clicking the checkbox next to the appropriate department on the legend. Hovering over an individual agent glyph returns a dialog showing property values for that agent. Users are able to use scroll bars to zoom on individual axes, or by using the wheel mouse. The user is using the mouse wheel to zoom, which zooms towards the mouse pointer. The visual design suffers from overplotting, limiting the usefulness of the application. Therefore, we utilize a clustering technique to reduce clutter. By selecting this option, agents are clustered into parent glyphs according to their proximity to one another, reducing overlap and clutter. A number indicates the number of child glyphs represented by each parent, and the glyph center indicates the proportion of agents from each department. Glyph bars are updated to display the mean values for all child glyphs. Hovering over a parent glyph returns a dialog displaying the number of agents represented from each department and the mean agent variable values. As the user zooms, parent glyphs are recomputed to fully utilize screen space. As the scene is zooming in, parent glyphs are continuously being recomputed and splitting into smaller clusters and individual child glyphs. Zooming out causes the child glyphs to merge into parent glyphs. A user option allows for the filtering of all bars that represent below or above average variables. Using this view and the above average filter, we are able to see that bars on glyphs with below average Net Promoter feedback scores are removed on glyphs with high customer effort score and a large number of holds. The clustering distance metric can be adjusted to control the amount of glyphs displayed. Increasing the clustering distance decreases the number of glyphs, while decreasing the distance increases the number of glyphs. An option is also available to cluster into individual departments, skill, team, or call center site. Here we cluster agents into their call center departments. This gives the mean variable values for each department, allowing for comparisons to be made between each department. Changing the axis so that we have customer effort score on the y-axis and the average hold duration on the x-axis, we can see that 3 distinct clusters of departments can be seen. The sales and billing departments have a significantly longer hold duration in comparison to the credit, company and collections departments, suggesting that agent resources in the sales and billing departments should be increased. The distance metric can be used in conjunction with a categorical cluster. In this case, glyphs will only cluster if they share the same department and are within the distance metric. This feature is particularly useful in finding agents that have strange behavior in comparison to others in their department. The user changes the x-axis to display the number of calls per day and the y-axis to show the percentage of short calls. In this example, we have an agent from the customer services department who has less short calls in comparison to others from the department and averages more calls each day. Using the filtering option further highlights this lone agent. This lone agent among 6,500 agents deserves special recognition. Another example of behavior different from the norm is this agent from the credit department, with 100% of their calls being classified as short. Short calls are calls that last less than 5 seconds, too short for a meaningful interaction. By using the on-mouse over feature, we can see that only 3 calls were handled by this agent, who may warrant special attention. We further demonstrate the utility of the application with a brief case study of factors affecting customer satisfaction and how well the customer satisfaction correlates with customer effort score in different call center departments. Customer satisfaction is measured by a feedback score known as the Net Promoter Score on a scale from 1 to 10. Customer effort score is a derived multifaceted metric to determine how much effort a customer made in contacting the call center. Some of the factors that affect this are the call duration, the number of transfers, and how long a customer was on hold for. The user has selected customer feedback for the y-axis and the customer effort score for the x-axis. The main drivers of customer effort have been mapped to the glyph bars. The percentage of calls transferred is placed on the 6 o'clock bar on the glyph, with average call duration on the 12 o'clock bar and average hold duration on the 8 o'clock bar. The user filters to show only the retention department, then adjusts the x-axis accordingly. Feedback scores of -1 represent agents who have not received feedback. Therefore, they can be removed using the y-axis zoom. A negative correlation can be seen, with an increase in customer effort returning less customer satisfaction. Clustering is enabled to reduce clutter. Noticeable now is that calls with a low feedback score also have a large percentage of calls transfers, as indicated by the 6 o'clock bar. Switching the x-axis to the percentage of calls transferred and adjusting the axis accordingly confirms this. The user decides to cluster agents by their team to see what effect this has. It is noticed that the 8 o'clock bar, representing hold duration, is slightly longer on calls with a lower customer feedback, so the x-axis is changed to hold duration to study this further. Some correlation can be seen again, but noticeable again is the difference between teams with a high percentage of transfer calls and those with a low percentage of transfers, as indicated by the 6 o'clock bar. The user decides to see how the sales department compares. Immediately, a relationship between average hold duration and customer feedback is seen. Changing the x-axis to customer effort shows the same correlation. Performing similar analysis to other departments shows that feedback score correlates with effort for the tech support and billing departments. However, this is not the case with the credit, collections, and customer services departments. Development of this application was guided by our industry partners from multiple feedback sessions. The following extract comes from one of our evaluation sessions with the domain experts.
And the whole thing looks really good. Looks really good to me, really flexible.
Good.
Looks like it does an awful lot.
Yeah.
I really like it.
Thank you for watching.